Symphony of the Seas is in fact the largest passenger ship in the world today. It's even been recognized in the Guinness Book of Records. But what do we mean by the largest? It's not actually about the size when it comes to ships. Another liner in the same class, Harmony of the Seas, is longer than Symphony by several centimeters. But the Symphony has the largest displacement, the amount of water that is displaced by the ship due to its volume. Remember Archimedes' principle? Well, the Symphony has a displacement of 228,000 tons. That's equal to 5 Titanics. A giant like this isn't able to enter just any port. In Russia, for example, there is only one that can accommodate this ship, in Vladivostok. While the most advanced places in this regard are countries in Asia, Europe, and of course, the United States. Port Miami, Florida's major seaport. Here is its cargo terminal. All in all, it has rather modest traffic figures. About 1 million containers move through here per year. So we've got maybe a dozen cranes and just a couple of ships docked here at the moment. This isn't what this port is famous for, of course. That would be something else. That I'll show you right now. Here is the world's largest passenger terminal for cruise ships. Here, behind my back, that's not a multi-story building, no. It's the stern of a ship named Symphony of the Seas. 6,000 people are boarding it right now. And in the span of just a year, 5,600,000 people pass through this passenger terminal. That's more than the entire population of Miami. It's not so much that Americans are particularly fond of cruises, as it's that Miami is ideally located. Mexico, Cuba, and the Bahamas are all just a few days' travel from here. That's why this port was chosen by several major cruise companies to be their starting points. You can see that right now 6 different liners are all preparing to leave, and they belong to 4 different operators. But Symphony of the Seas immediately stands out from the others due to its incredible size. At about the same time when a shipyard in France began to build the ship itself, several thousand miles away from Europe, on a completely different continent, right here in Miami, they began to build this terminal. Again, essentially, it turns out that the ship wasn't built to fit the size of the port, but the port was built to fit the size of the ship. The main feature of this terminal, or maybe I should say the main art installation in this terminal, is these 2 rotating propellers which are exact copies of Symphony of the Seas propellers. They each have a diameter of 50 feet, and the weight of the real ones is 200 tons each, but these are of course a bit lighter. By the way, the ship doesn't have 2 of these propellers, but 3. They're mounted on podded propulsion systems, so-called azipods. Those are made up of huge pods which are suspended from the bottom of the ship at the stern. They are capable of rotating 360 degrees, meaning azipods provide the giant vessel with easy and quick maneuverability. I will show you in more detail how all this works in the second part of the episode, but for now, I will only say that these azipods were manufactured in Finland, and then sent by sea to the French town of Saint-Nazaire, the home of the shipyard where the vessel was built. In general, Symphony of the Seas is a huge construction set consisting of hundreds of thousands of parts which were manufactured in dozens of different countries located on different continents. So it began to unite people from distant corners of the world even before the first passengers of various nationalities ever stepped on board. Boarding a ship is very much like boarding an airplane. Even these gangways, well, those who often fly, they know that they are almost identical to those in airports. Well, maybe these are a little wider. Only planes have a maximum of 2 such gangways, while the largest airliners might have 3. But here there are 5 of them. And another interesting peculiarity, those who fly know that boarding of an aircraft starts about an hour before departure and stops 20 minutes beforehand. But since 6,000 people have to go through here onto the ship, boarding begins 6 hours before departure, so that everyone has time to make it on board. This is why cruise ships almost always depart in the evening. All day long, passengers come on board, get used to their cabins, and then closer to sunset, the gangway is finally pulled back, the doors are all closed, and the ship rolls away from the quay wall. Thanks to those azipods that we mentioned earlier, and an additional tail rotor, Symphony of the Seas completes this difficult maneuver by itself, without the help of any tugboats. Only a small Coast Guard patrol boat moves ahead of it, dispersing small pleasure boats and ferries out of the liner's path. This moment, already routine for the crew, is always quite exciting for the passengers, who at the moment of departure always pour out onto the upper decks. After all, the sea, and even more so these calm oceanic waters, aren't anything like railroad tracks, and these gigantic ships are actually seen off in a very different way from trains.
Как ни шути, волнений больше, ведь ты уже не на земле. Как ни ряди разлука дольше, когда плывешь на корабле.
However, the passengers will hardly have time to feel any separation woes on the ship. This giant floating city is designed to be fun and entertaining. The liner is 1,053 feet long, more than 3 soccer fields. Its width is 216 feet, and in this huge space there are 28 restaurants, 3 swimming pools, 10 jacuzzis, a theater equipped with the most complex Broadway machinery, an ice rink, a tropical park, a water park, a fitness center, a casino, and many shops and boutiques that constantly keep tourists in a state of shock and awe and continuous happiness. It is somewhat reminiscent of something out of a fairy tale, a place where you need only eat, sleep, and drink. When you look at the map of the ship, these are posted everywhere here, you get the feeling that the ship is some kind of toy. Yes, there's 12 passenger decks. Yes, it says 2,750 cabins, but what do all these numbers mean? You only start to get a sense of it right here in the elevator atrium. Just take a look. 6 high-speed elevators transport thousands of people to a height of 229 feet around the clock. And at the same time, all this is now moving at a speed of 30 miles per hour in the direction of Mexico. Incredible. Even more incredible is the fact that the ship is directly controlled by only 3 people while it's in motion. And among them, there is no boatswain, no skipper, no helmsman. Even the captain himself isn't on the bridge all that often. Today, the people who control the ship from here, from the captain's cabin, are no longer what you might imagine, sailors with tough, salty, weathered faces. They look more like office workers, and this place resembles some kind of control room or something. And here's my biggest disappointment. This is the captain's chair. There's no steering wheel. The ship is controlled by 2 special joysticks. They're called anti-mice. In general, everything is technologically advanced, safe, highly scientific, and completely lacking in romance, for heaven's sake. You no longer have to pore over maps to plot a course. The navigation system stores all the necessary routes in its memory. The computer plots the path, taking into account the shallows, reefs, and other features of the topography of the seabed, and satellites track the position of the liner. An operator just needs to plug in the arrival time for the next point on the route, and the computer will even calculate the speed with which the ship could move. It's kind of like autopilot. The next time a person will need to directly intervene is the moment the ship approaches a port. The width of the ship, I will remind you again, is 216 feet. Therefore, side mirrors here clearly wouldn't cut it for parking. So when parking, well, when mooring that is, they use a special mooring console. Here it is. By the way, it sticks out from the side of the ship a bit, you see. It kind of hangs over the side for better sight lines. There is a second, identical control panel on the other side of the liner. Either the left or right one can be used, and that's determined by which side of the ship approaches the quay wall. The compass and binoculars found here are likely more of a tribute to maritime tradition than anything else. Mooring here, again, takes place with the help of space satellites and GPS. When the ship finally gets into the correct position, it is, you might say, tied to the pier with special ropes. This is almost the only step of the whole docking process that looks pretty much the same today as it did several centuries ago. The huge ship is held in place by means of 22 of these extra strong ropes, each about 5 inches in diameter. Right now, they're stretched like piano strings, they even vibrate a little, and here's something amazing. If you knock on the rope, you'll have to take my word for it, it's very solid. It feels like there's some kind of metal core inside, but in fact, this is not the case. The rope is woven from a variety of synthetic threads. They're very strong, they have a high elasticity coefficient, they're able to handle the highest levels of stress, but at the same time, as you can see, the rope is already quite frayed, despite the fact that it's less than a year old. It'll be changed soon. Previously, mooring ropes, or to be more nautically accurate, mooring lines, were woven from hemp. The use of polypropylene fibers is a more recent development. These ropes turned out to be much stronger, and what is even more important, they don't absorb moisture, so they're much lighter. Curiously, on these ropes from the 21st century, these shields from the 16th century, if not earlier, are still put to use. They're called rat guards and are needed to keep rats from the shore from running up the mooring lines onto the ship. Today, this small Mexican port has a real full house. 3 cruise liners arrived here at the same time, and all the berth walls are occupied. Here, Symphony of the Seas, 6,000 tourists, Norwegian Dawn, about 4,000. And lastly, a ship called Celebrity Reflection. There are about 5,000 more people on it. In total, about 15,000 people are coming ashore all at once. This, by the way, often becomes a serious headache for the staff of the ships. In the evening, when tourists come back here, relaxed, we'll say, after sampling some tequila, they have a bad habit of trying to board the wrong ship. But there haven't been any cases of someone sailing away on the wrong liner, not yet. The stewards and representatives of the Port Logistics Service work like clockwork and don't drink tequila, just like the other 2,000 crew members of Symphony of the Seas who, unlike the passengers, don't go ashore when the boat docks. While tourists are exploring local attractions, on the lower decks, preparations for the main task of the day are underway. Cooking dinner for 6,000 passengers before they get back on board. And for this, you first need to bring up several tons of products from the storage area to the galley. Usually, the entire selection of products for the cruise is loaded onto the ship at the port of departure. The liner can only take water on it interim stops, and even then, only bottled water. They are very afraid of the possibility of food poisoning here. Since thousands of people live compactly on the ship, a simple case of E. coli can turn into a real epidemic in the span of just a few hours. And even putting that aside, not all countries can provide products of the high quality that Symphony chefs require. All the refrigerators and storage boxes here open automatically with the press of a button, but there is one door whose button is behind a lock. Thankfully, I have the magic key. You've probably already guessed what's behind this door. Here it is, the holiest of holy of Symphony of the Seas storage area. Here are several thousand bottles of elite red wine. Milk, meat, seafood, vegetables, frozen products, fish, all of that and more is stored in the dozens of other refrigerators. Anything and everything that might be needed to prepare the 350 different dishes that can be found on the ship's restaurant menus. Of all the foodstuffs stored on the ship, only 2 products are honored with having their own private refrigerators. Well, simply because they are the most consumed items. First, we've got bananas. Here are plenty of boxes with yellow ones, and there are also boxes with green ones. They will finish ripening during the cruise. And the second product is the most popular. What do you think it is? I'll show you now. Eggs. 120,000 eggs are eaten on board every week. Moreover, bananas and eggs are, as economists and logisticians say, goods of inelastic demand. Their consumption rate, and hence the required plant amount, is easy to predict. Things are more interesting when it comes to the rest of the products on board. A specially developed computer program analyzes the number of passengers and their nationalities even before setting sail, and depending on that information, it gives recommendations on how many of this or that product you need to take with you on any given voyage. For example, if there is a large number of Latin Americans on board, more meat and spicy foods will be added to the menu. If there are more Asians, they'll reduce the amount of dairy products, and if Indians are prevalent, they will increase the number of curry dishes, but at the same time they will bring less beef. One of the main delicacies of any haute cuisine is of course the Atlantic lobster. Here he is, such a handsome guy. This dish, by the way, is not cheap, therefore it is very rare. And even here it's cooked, well, not all that often. It's a one-of-a-kind item, one might say, made 6,000 times every day. Each of these workers, there are mostly Filipinos working here, shells about 500 lobsters a day. Those of you who have ever shelled, for example, crayfish, can imagine how much work this entails. On just 3 decks, more than 1,000 people are employed in this huge floating kitchen, 250 of whom are professional restaurant chefs. They fry, boil, flambe, sauté, and whip around the clock and in shifts. Take breakfast rolls, for example. 12,000 of them are baked here every day. In fact, the responsibility of the cooks here is enormous. The clients on the ship are very demanding, the products are expensive, and the cooking portions are gargantuan. Therefore, the slightest mistake in the proportions of ingredients can cost tens of thousands of dollars. Well, for example, tomato soup, 160 liters of it. If it's a little bit overcooked or undersalted, that's it. Eat it yourself since no one else will. Seating and serving several thousand people in the liner's restaurants at the same time is a separate logistical task, and they strive to make it so that customers don't have to wait more than 15 minutes for an order. Several hundred waiters of 50 nationalities cope with this task, each of whom must speak at least 3 languages. And bartenders should know at least 5. Well, technically there was an exception made to that rule. In general, everything on this ship suggests that this is a high-tech structure created according to the latest leaps of science. For example, in this bar, drinks are mixed, well, probably in the most progressive way on the planet. All you have to do is make your choice on the tablet screen. So, yes, we confirm, and that's it. We go up to the bar and that's it, enjoy it. There's an old Russian song. How does it go? The robots work and people are happy.
До чего дошел прогресс, до невиданных чудес, опустился на глубины и поднялся до небес. Позабыты хлопоты, остановлен бег, вкалывают роботы. Счастлив человек.
Not bad. Another high-tech installation, though it doesn't seem like one at first glance, is a huge park with its own microclimate, which is laid out in the central part of the liner. Here, among the shady alleys, serenaded by the songs of specially brought in crickets and frogs, it's easy to forget that you are actually somewhere in the middle of the ocean. In this park, not many, just no less than 10,000 plants have been planted, from rose bushes and orchids to lemon trees. And all this grows here, blooms and flourishes. What's the secret? I'll show you. Here, for every plant, maybe I'm not being generous enough. Well, for almost every blade of grass practically, there's a special tube placed next to it, which from time to time, now you will probably see it, yes, fresh water is sprayed out. And not just water. Now I'll show you the irrigation station. Here, through these pipes, 4 tons of specially prepared water are pushed every week. Here's the main secret. Here in this blue barrel, fertilizer is kept in here. Water passes through it, carries away some of the fertilizer, and carries it to the plants. So thanks, in fact, to this seemingly unremarkable little device, this whole huge blooming park exists. Another secret of the permanently green park is its honeycomb structure. There was no solid ground here. All the plants, from the trees to the grass, are inserted into special cells in separate segments, small plastic boxes. It turns out to be something like a huge puzzle. If one of the segments suddenly starts to get sick or dry out, it's simply changed out for a new one upon arrival at the home port. This wall of vertical landscaping in the ship's central park follows the same principle. The gardener, who turns out to be a bit of an industrial climber as well, simply climbs in the bucket and changes out the parts of the wall that he doesn't like and discards the old segments. There is no time for sentimentality. Nothing should prevent people from enjoying their time here and being filled with joy. Remember what I said at the beginning, that this episode was about a cruise ship without romance and without leaving anything out? And what could be less romantic on a ship than the machinery room? In the lower part of the ship, where tourists aren't allowed, day and night there's the roar of machines working in the semi-darkness, and these are what makes this entire giant city on water move. Symphony of the Seas is 6 diesel engines with a total power capacity of more than 100,000 horsepower. For a point of reference, that's approximately the power capacity of 1,200 cars. However, not even close to all of this energy is spent directly on moving the vessel. The ship consumes colossal amounts of electricity. For example, for lighting, there are about 140,000 light bulbs on the liner. Also, electricity is spent on the operation of air conditioning systems and on the production of large quantities of water vapor. Yes, despite the fact that steamers and steam engines are a thing of the past, modern liners still use steam. A lot of steam. No, it of course no longer rotates the turbines as it did, for example, on the Titanic, but steam is needed for more domestic purposes. It's a simple method for heating the water in showers and bathrooms, and it also heats different spaces when necessary. However, those aren't its main function. Steam is necessary for the heating systems for the huge fuel and oil tanks, and it's also used in fuel-oil separators. It's consumed by the turbo drives of some pumps, and, well, if it's necessary, for several other important machines on ships. It's consumed by the turbo drives of some pumps, and, well, it's still necessary for several other important machines on ships, even in the 21st century. Moreover, it must be perfectly clean so that impurities don't build up on the walls of the steam lines. Therefore, it is created from distilled water. But where do they get such large amounts of distilled water? It's produced right here on the ship using giant distillers. Here they are. There are 3 of them. The principle of operation is very simple. Well, it's basically a big tea kettle. This is where water from outside comes in. Here it's boiled, steam accumulates in the upper part of this chamber, and the sea salt settles down at the bottom. So after a while, overheated steam, there's a lot of it, enters this chamber. Here it condenses, and as a result, the finished distilled water is drained through the pipe. And the leftover salt? No, it's not used in the kitchen. They just throw it back into the sea. Several tons every day. This does not harm the environment in the slightest, since in essence, they're only turning the ocean's own salt back to itself, while keeping the moisture on board. Then the distilled water. Here it goes on to be filtered, and then it enters the boiler. Well, again, the principle of its operation is about the same as that of the boilers, which many of us have in our bathrooms at home. There was a small burner here at the bottom and a tank of water on top. A very large tank, 5 tons, and it starts boiling in just a matter of minutes. In the end, the resulting steam is used for its intended purposes. Moreover, part of it, when it condenses again, is sent back to the boiler. This is the so-called reverse cycle. But most of it is irretrievably lost, and therefore the reserves of distilled water have to be replenished all the time. It's also needed to freeze an actual skating rink on the ship. Here you can skate during the day and watch an amazing ice show in the evening. That includes a number of Russian figure skaters. And by the way, the ice here is of a very high, one might say, Olympic quality. The ice on the rink measures in at about 3.5 inches thick. Well, surely many of you have seen an ice resurfacing machine on TV, or maybe even in person. They've got the exact same kind here, though maybe it's a little smaller than typical ones. By the way, since this ice is frozen from desalinated seawater, it doesn't freeze quite as well. And according to the skaters, this ice is softer than that on which they are used to performing on land. To be honest, it's hard for me to imagine how ice could be soft, but what is absolutely certain is it's incredibly clean, distilled. I even gave it a taste, but it was really nothing miraculous, just your typical snow. The total weight of the ice in the arena is several tons, and a refrigeration unit is needed to freeze it. Again, it's about the same as the one used on professional skating rinks and professional arenas. Well, this one might be a little smaller. It's located, as you would expect, in the area under the stands. The principle of its operation is very simple. Through special pipes, here they are, wrapped in thermal insulation, water and refrigerant with a temperature of 14 degrees Fahrenheit are pumped to the arena. This freezes the ice layer by layer. It takes about 5 days to prepare the entire ice rink. The owners and designers of Symphony of the Seas claim that this ship is not only the largest in the world, but also the safest. There are so many different safeguards in place in its control system that it is argued it's almost impossible to lead the liner into disaster, even if you were to deliberately try to do so. Still, in the event of an extreme case, there are means of evacuating the ship on board. They have to accommodate the evacuation of all passengers and crew if something were to happen. These lifeboats, to match the ship, are the largest in the world. Each has a capacity of 370 people. There are 18 of them on the ship. Moreover, they are kept fully prepared at all times. Their fuel tanks are filled, they have a cruising range of about 155 miles. There was a special supply of dry rations and water on board in special sealed boxes in the event of a disaster. There would be no time to bring it all from the ship. In general, everything is thought out to the smallest detail. This unsinkable and waterproof plastic jar, for example, contains signal flares. In addition to the huge boats, there are also many rafts that inflate themselves in the water and several of these high-speed rescue boats. They are used to coordinate action and quickly help people who find themselves in the water. The crew must participate in evacuation exercises at least once a month. This vessel has never seen a real red alert, but thanks to constant training, 2,000 crew members are ready for any turn of events, 24 hours a day, 7 days a week. The ship also has its own waste recycling plant. Here it is. This, for example, is a machine for pressing cardboard packaging. Here, cans are collected. Then they are all crushed into these large bricks. Cellophane is processed here. At first glance, it is a little paradoxical how they deal with glass bottles. I'll show you now. They are simply broken into little pieces so that they take up less space, and they are sorted as follows. Here we have a big bag with dark glass. Here we have broken transparent bottles, and here we have green glass. And here's what's surprising. As is everywhere else on the ship, in this waste recycling shop, Everything is kept perfectly organized. There isn't even an unpleasant smell here. The creators of this ship seem to have a thing about cleanliness and environmental friendliness. In a good way, of course. For example, the liner's engines burn several tons of diesel fuel every hour. But at the same time, not black, not even blue, but exclusively white smoke comes out from the Symphony's exhaust pipes, all thanks to scrubber cleaning. Well, if to simplify it as much as possible, the exhaust gases are washed with seawater. This dirty water is then maintained and stored in special tanks until the ship arrives at a port, and only carbon dioxide with a minimum amount of soot and impurities is released into the atmosphere. Scrubbers and engines are managed from this control room. It's located in the very center of the ship, almost at the waterline itself. Therefore, there are no huge windows to be found here, like on the captain's bridge, but there are 51 monitors which display thousands of different parameters. The largest touchscreen control panel even had to be hidden in the ceiling. Here it's already pretty cramped without it. There's a special emergency phone in this control room. Well, there's a telephone for singular emergencies. Its peculiarity is that it will work in any case, even if, say, God forbid, of course, all systems here completely fail and all power is lost. By what means? I'll show you now. Good old inductive coil. This technology, well, I don't know, it's probably around 120 years old, and it's very strange to see it on this ultra-modern ship. But technology such as this is sometimes the most reliable. Hello? Bridge? Apart from that, the equipment in this control room is of a quality comparable to NASA's Flight Control Center. And the whole vessel is practically a spaceship. Sure, they're not jet, but diesel-fueled V-engines. But each weighs about 200 tons. 2 of them are 16-cylinder, 4 more are a bit smaller with only 12 cylinders. These giants were made in Italy, and then they were sent by a special convoy, first along blocked-off roads, and then delivered by sea to a shipyard in the French town of Saint-Nazaire. Building each of the 6 fiery hearts of this monster was such a difficult technological task that we decided to show it to you in more detail. That's why we're taking the reverse path to the engine, from the Caribbean Sea into Miami through France to the Italian industrial port of Trieste. The company that makes the world's largest marine engines in Italy is actually from Finland. It's called Wärtsilä. It got its name in honor of a small Finnish village where this business once originated. It's curious, but today the urban-type settlement and the Wärtsilä station of the October Railway are part of the Sortavala region of the Republic of Karelia, a typical Russian single-industry town with a modest budget. At the same time, Wärtsilä has an annual revenue of several $billions. But back to the engines. Each of them consists of several thousand parts. Some of them are made right here in Trieste. Some come from subcontractors. Cast and forged blanks, for example, are sent from a metallurgical plant in the Czech Republic. The so-called connecting rods come here to the plant in this form, crudely forged, very coarse to the touch. Here, they are then installed in these machines. They each weigh 330 pounds, by the way. Many of us, when we were kids, not everyone of course, in shop class did something similar, carving out various objects. It's about the same here, only the size is much larger, and the accuracy is very high. As a result, the connecting rod is worked to, well, just to a mirror shine. After the lathe finishes, the connecting rod is then married to the piston and installed in the cylinder. In general, everything's familiar. Everything looks like a conventional internal combustion engine. But in this place, you feel like Gulliver in the Land of the Giants. The size of the parts is daunting. Everyone who has ever gone over the engine of their car, seen the pistons, immediately recognized them. Well, this one, believe me, is exactly the same. Well, a little bigger. This weighs about half a ton. And the volume of the cylinder in which it works is 6.5 liters. That, by the way, is a bit more than the total volume of my car's engine. Well, alright, not a bit more, several times more. And this, I repeat, is only one cylinder, and in 2 of the engines on Symphony of the Seas, there are 16 cylinders, just like this one. And the main difficulty here is that huge parts, that sometimes weigh several tons, must fit together perfectly. After all, there is so much force and heavy loads involved that the slightest deviation or inaccuracy can send the engine off the rails, and in the open sea, that can threaten a catastrophe. Therefore, manufacturing margin errors are as severe as with Swiss watches. Well, by the way, using the crankshaft as an example, you can easily understand the principle of operation of a piston engine. Look, in this position, for example, the piston would be in the upper position, and this crank pin is also up. At the same moment, the other piston is in the lower position, and the crank pin, respectively, is at the bottom. Thus, the pistons move up and down, and the shaft rotates. Everything is very simple, but the most amazing thing is that this particular shaft weighs 25 tons, its length is 26 feet, and it's made of one single solid piece of metal. Just unbelievable. By the way, there are only a few metal laths in the world that can carve a 26-foot item like this from a multi-ton bar of high-strength alloy steel. The turner's worst nightmare here is to screw up even one detail. The crankshaft is worked on for several weeks, and it costs more than $1 million. Ultimately, after numerous checks and tests, the crankshaft and thousands of other parts are sent to the assembly area. In a few more weeks, the engine is finally ready, and now tests await it. If everything is in order, the engine is rolled back onto the ship, all technical fluids are drained, and it's checked again and again. In the testing chamber, the engine has already been checked out by numerous automated computer systems, sensors, and so on and so forth. But no one has done away with the good old visual control test. Everything here, again, is like in a car. We open the hood and look inside. Perhaps the most important difference between this engine and a car engine is that there are 12 of these hoods, or rather viewing windows. Behind each of these windows is one of the cylinders and valves connected by a connecting rod to the crankshaft. If you wait for the oil to drip down from the parts, you can simply see with your eyes if any jams or other metal defects have formed during the tests. When at this stage the inspectors give the go-ahead, the only thing left is to pack up the engine and send it to the customer. But that's easier said than done. Anyone who has ever, transported, say, a dresser knows that the most necessary thing to get that done are duct tape, some styrofoam. Oh, here we have some. Well, and a lot of bubble wrap. When moving a finished engine, everything is about the same. All protruding parts are carefully wrapped with these foam corners, sealed with tape, cling wrap, and so on and so forth. Well, in general, everything is the same as when moving furniture. There is a slight difference, though. The weight of this dresser is 180 tons. It takes a week just to get it ready for transportation. By the way, at the same time, road services and a special platform, the only one in Europe that can support such a weight and size, are being prepared for the giant's move to the port. Only here, at the very end, in the finished goods warehouse, can you begin to understand the true scale of this giant engine. Its height is about that of a 3-story building. It weighs several hundred tons and generates the amount of electricity that would be needed for a small Moscow neighborhood. The actual biggest mechanical heart in the world of the world's biggest cruise ship. And Let me remind you, Symphony of the Seas has 6 of them, and although at the same time, even at full speed, usually no more than 3 of them are working, the fuel consumption is still massive, and that's why the company that owns the ship uses a little trick. At the starting point of the journey, in Miami, they take on board only as much fuel as is needed to reach the next port, where fuel is cheaper, and when they're already in Uruguay or Mexico, for example, the liner is filled up with diesel all the way. Thanks to this, the ship owner manages to save several $1 million per season. However, there is one caveat. For some reason, the fuel from these countries often contains water. By accident, of course, I'm sure, but this is unacceptable for the engine. Therefore, all fuel is cleaned directly on the ship before being fed into the combustion chamber. But how can several tons of fuel be cleaned per hour and when moving at full speed too? And here, centrifugal force comes to our aid. Fuel enters these separators, which are in essence huge mixers, and it's spun at a breakneck speed. What happens in there? Water, which is heavier, is forced out to the walls, and the oil product, as the lighter portion, accumulates in the center and then enters the engine. 5th grade physics at work on the largest ship in the world. At the same time, the fuel in the separators is also heated. That makes it more runny and it therefore burns better. By the way, the liner has an electric drive. No, its powerful internal combustion engines do not directly rotate the ship's propellers. They spin generators that generate electricity. And then, along the high voltage lines hidden in the bowels of the liner, the current travels to the electric motors, which spin the propellers. This diesel-electric circuit makes the vessel more maneuverable. After all, an electric motor, unlike a piston one, can stop and change the direction of rotation almost instantaneously, and it doesn't need a gearbox. The motors, together with the propellers, can also rotate 360 degrees around their axis. Therefore, it becomes very easy to operate the liner. However, even the most high-tech devices and numerous automatic safety systems are not able to 100% protect the ship from basic human error. 3 weeks after we filmed this episode, in the same Mexican port where Symphony of the Seas stopped for an afternoon, 2 cruise ships managed to collide. Oh my God! There were no casualties, both ships even continued on their voyages, but still, this situation once again reminded me that regular emergency evacuation drills on the ship are not at all excessively precautionary. However, maybe no less dangerous than a collision with another ship would be a situation in which 6,000 passengers were left hungry. They almost seem to fear this even more here. The 350 exquisite dishes on the menus of 28 restaurants will satisfy even the most demanding customer. We already showed you how this monster's kitchen works in the first part of this episode, and perhaps at this point the question occurred to you. How can you quickly wash a large number of plates, mugs, glasses, and cutlery after dinner? On this ship, in general, all technological processes that can be are built on the principle of a conveyor belt. Well, this is logical, of course, because this is one of the most effective forms of labor organization. And here in the kitchen, the dishwasher is also one huge conveyor machine. Come with me, I'll show you. Sorry, dirty dishes are being loaded from that side and clean ones are already coming out here. The whole process takes less than 1 minute, extremely fast. Mr. Clean would be impressed. There was no other choice because after every dinner, about 50,000 dishes have to be washed, and that's not counting the kitchen utensils. Though it may seem like less than a critical machine, the dishwasher on the ship is actually such an important unit that it has a twin backup in case the main one breaks. Another one of the liner's important machines is the washing machine. It was built to special order and installed in the bowels of the ship at the time of its construction at the shipyard. A whole 2 technical decks of Symphony of the Seas have been given over to laundry. Here, about 10,000 towels are washed every day. They also tried to automate this process as much as possible. Housekeepers collect dirty towels from the rooms, sort them by color, and send them to the laundry decks. Here, they are loaded into this receiving bin. Then the towels go through the chute to this washing machine. one of the world's largest washing machines. Its length is 36 feet. And this one differs from the ones in our houses, not only in size, but in that all the cycles take place simultaneously. Here, it's soaking items. Here is the actual washing. Here is rinsing. Here is already spinning. That means that while dirty towels are entering the front of the machine, clean ones are coming out from here. And all this is happening around the clock, nonstop. After each batch of towels, there's about 100 each. Comes out of the washing machine after spinning, it looks like a large blue pill. Now, each towel needs to be shaken out, smoothed, and rolled beautifully. This step is done manually. There are mostly Filipinos working here, and for some reason only the men of this hardworking nation seem to be the ones managing to perfectly roll thousands of towels every day without complaint for months on end. And here, they also wash hundreds of sheets and pillowcases around the clock. Well, homeowners know that the most difficult thing to iron are sheets and duvet covers. It's really quite time-consuming to do with an iron, but here you have to iron 2,000 sheets every day. And that's why they installed this machine here. It not only irons the sheets, but also, this is the most amazing thing, I'll show you now. It folds them. Look, in an ideal way. Not just anyone can do that. In short, I want one of these for my house. Only thing is, I'm afraid it won't fit into my laundry room. The laundry employs several hundred people. There's more than 1,000 in the kitchen. Dozens more are in the engine room and on the bridge. A huge army of the crew invisibly makes every second of the stay of the passengers on this ship unforgettable, comfortable, and safe. And yet the passengers themselves will never see most of them. Only service personnel who are in direct contact with tourists are allowed to climb up onto the passenger decks. That includes waiters, maids, bartenders, salespeople, hairdressers, and other staff. Others, sometimes for several weeks at a time, don't leave the depths of this monster and go out into the sunlight at all. But keep in mind, first of all, they are well paid for it, and second, at the end of the day, they work on the largest cruise ship in the world. And although they can't take in the incredibly beautiful sunsets of the Caribbean Sea from their own balcony, behind the walls of their cabins, which are located on the lower decks, you can hear the rush of water. Yes, I promised that it would be a story without romance, but still.
This plane had to complete a long journey before arriving at Frankfurt Airport. And what's more strange as it may sound, this monster began traveling before it was even born. After all, each A330 consists of 6.5 million parts and components produced by 1,500 companies in 30 countries all over the world. The A380 is the largest passenger aircraft in the history of world aviation. It's manufactured by Airbus. The maximum capacity is 853 passengers. The length of the liner is almost 73 meters. The wingspan is almost 80. The height is 24 meters. In fact, this is the height of a 9-story building. And the area of the 2 passenger decks totals 550 square meters, which is larger than the area of a football field. The A380 is such a complex and high-tech machine that none of the EU countries were able to take on this project alone. As a result, this giant aircraft came into creation thanks to its 4 parents: Germany, France, Spain, and Great Britain. The wings are made in the foggy Albion, the tail is made in the homeland of Columbus, and the final assembly is done in France. But the most complex and crucial stage, the production of the fuselage sections, was entrusted to the meticulous and scrupulous Germans. The fuselage of this giant consists of 3 huge sections: a nose, tail, and middle. It is also called the center section. All of them are manufactured here in a huge special hangar near Hamburg. A lot of time and thought went into selecting the location. On the one hand, there had to be an airport nearby, as many components arrive here by plane. On the other hand, the presence of a navigable river was necessary in order to— mind you, why a future flying monster needs a river, you will find out a little later. As a result, the plant was built on the banks of the Elbe. The fact that it flows into the Atlantic Ocean played a decisive role in the choice of location. To accommodate more passengers on the plane, Airbus designers decided to make it a full two-story plane and not with a hump like on Boeing's, for example. This is where the 8 in A380 comes from. This figure somewhat resembles the cross-section of an airplane fuselage. Also in the East, it is believed that the number 8 brings good luck. And the first customer of these giants here was actually Singapore Airlines. The fuselage sections are assembled on huge slipways. They're somewhat reminiscent of scaffolding. The parts of the casing are thoroughly inspected, checked, then technological hooks are screwed onto them, which are then used so a crane can lift the parts. Afterwards, individual segments are assembled on the slipway to form a finished part of the fuselage. It all looks like a huge 3D puzzle. In just one day, the body of the future section appears from a dozen pieces. There are 6 assembly slipways in this hangar. The section simply transfers from one to another, gradually drowning more and more in wires, cables, lines, hoses, pipes, tubes, air supply systems, and internal lining. Basically, what you have here is a giant conveyor belt where a section spends several days at each stage. The aircraft body consists of only 75% aluminum. The remaining 25% are special composite materials. For example, this part is the plane's tail, made of especially durable fiberglass. Based on its characteristics, this material is pretty much the same as aluminum, but significantly lighter. Theoretically, it would be possible to make an entire plane out of this, but it would simply be very expensive. Besides, according to developers, the trickiest part in creating the aircraft is the issue of reducing its weight. This monster is so huge that its own projected weight could have prevented it from flying. This problem was solved not only thanks to fiberglass, but also augmented aluminum alloy. As a result, only 40% of the center section consists of volatile metals, while the rest is made up of composites. After the body of the sections is ready, it is carefully wrapped from the inside in a coat, I guess. It's a special heat-insulating material due to its ability to retain heat. A thin layer of such fiber replaces a 10-centimeter layer of glass wool. But that's not even the main thing. In the event of a fire, God forbid, of course, this material is capable of holding temperatures of several thousand degrees for 90 seconds. Every square centimeter of this aircraft has been planned down to the tiniest detail. The thermal insulation material, for example, arrives in segmented pieces based on special templates. Even if the worker wanted to, he wouldn't be able to attach the wrong segment to the casing. It simply wouldn't slot in with the others. So this shirt will fit our monster like a glove. We all know, of course, that an airplane is a tough nut to crack, but I'm afraid we can't even imagine how complicated it is. For instance, when we enter the passenger deck, we can't even begin to presume what's under our feet. Now you have a unique opportunity to see this. Hundreds of wires, 1,000 contacts, but you know what? This is just for starters. You should see what's happening under the ceiling. One A380 has 530 kilometers of wires. In the cockpit alone, there are about 10,000 of them and about 40,000 of their various connections. They are everywhere. They weave through the entire plane from nose to tail. Every second, huge amounts of information and hundreds of volts must be transmitted through them. These are like the nerve endings of our monster. By the way, main connection lines are duplicated 3 times. If a short circuit occurs in the main line, the backup will cover it. Should the second fail, the third will take its place. And that means that mainline wires have to be fitted 4 times over. All this in conditions of extremely limited space and severe time pressure. To get to any given connection, workers sometimes have to use rather exotic tools. A dentist mirror, for example. But to be fair, this version's a little bigger. Fitting the electrics is the most difficult stage of equipping this section, which is why it spends the most time on this slipway. The huge structure is then transported further. At this stage, air supply and air conditioning systems are installed inside the section. By the way, none of the air ducts are metal, aluminum, or even tin. They're made of fiberglass. And again, because it is lighter. In fact, all the air in the A380, and that's 1,500 cubic meters, is completely exchanged every 3 minutes. As a result, absolutely everything is installed in the sections except the inner lining. After all systems have been checked tenfold, along with wires, pipe connections have been tested, only after this are the ends of the huge sections covered with fabric and the huge components of the aircraft rolled out of the hangar onto the pier. And here it becomes clear why the flying monster needs a river. Naturally, the logistics for transporting the components of an A380 are crazy. Here in Hamburg, several sections are loaded onto this specially built barge, after which it goes along the Elbe to the Atlantic, to the UK, where 2 aircraft wings will be overloaded. Now at that point, this ship turns around and heads back to France. The A380 is a monster that doesn't just fly, it's a monster that unites. The sections of the aircraft are so huge that there's no other way to deliver them to their place of final assembly other than by water. Huge fragments are loaded onto one of 3 River Sea-class ships specially commissioned for the A380. And so that onlookers have no doubt about their grand purpose, the side of each barge proudly boasts this inscription. Once again, due to the huge size and the high fragility of the sections, they did not even try to build a crane in this transshipment port. The parts of the future aircraft move inside the ship themselves, and to do this, the stern of the ship simply tilts down and the pier sags towards it, like a huge elevator. A huge number of different devices, tools, and machines were created specifically for the construction of the A380. One of them is this tow truck. Its main unique feature is that all of its 48 wheels, by the way, can rotate 90 degrees. And that means, if needed, this platform with a load capacity of tens of tons can actually move sideways. And this is a very important quality in conditions of limited loading dock space. The platform drives under the section, lifts it, carries it into the hold, and then places it there and moves out again. The whole operation takes about 15 minutes. And the most amazing thing is that the driver of this miracle car, there he is. Yeah, he doesn't even sit in the cabin but walks next to it and looks to see if everything is okay. A huge trolley that he controls using a remote. In just a few days, this huge ship with parts of the fuselage inside will be in Bordeaux, France. At the seaport of Pauillac, the sections will be loaded onto one of 2 river barges and sent up the Garonne. 100 kilometers of canals, sluices, and overhanging ancient bridges. In some places, the distance from the top of the section to the bridge truss is only 20 centimeters. However, never in the entire history of the A380 have any emergency incidents occurred with the fuselage and sections on the road. In the river port of Langon, the aircraft parts are again loaded onto road trains, and now they have to travel another 240 kilometers on the road to Toulouse, to the final assembly site. The path of our monster's components runs through small French towns. To minimize inconvenience to residents, the convoy of 6 huge trailers and 30 escort vehicles moves only at night. During the day, this huge convoy, stretching several kilometers, rests in specially constructed parking lots. But once darkness descends, everything here begins to move again.
Okay, we'll do it as we always do. The weather conditions today are good. The road is dry. Visibility is excellent. Arno, you're going to go in the front. Don't forget to remove the barriers in the cities. Speed is 15 to 25 kilometers per hour, no more. Good luck, everybody.
Each of them knows what and when to do something like the back of their hand. The drivers never change their order in the convoy. The trailer with the right wing of the plane always comes first. That's just how it came about. When the A380 parts were transported for the first time, that was the order. And since then, there have been no incidents, and they decided to leave this order for luck.
I transport different loads, but I consider this task the most interesting, albeit the most difficult, as all of it requires constant focus. On top of that, I'm first driver, but my two navigator operators always help me. One goes in the front, the other behind. They constantly radio in, telling me to drive a little to the right or a little to the left, but that's mostly necessary in cities, of course.
The route along which the Airbus night convoy moves is closed off. A police car, technical service vehicles, and a motorcycle escort are up ahead. In France, they don't even escort the president's limousine. About 40 minutes before the convoy passes through any city, the support group walking in front prepares the path, removing any interfering cars and sweeping the road clear. There shouldn't be any bumps whatsoever. Then they unscrew the posts separating the roadway from the pavement, and all this is done surprisingly calmly and, of course, politely.
All right, and there we go. Good evening, sir.
Good evening. While passing through the city, the convoy speed is reduced to 5 to 7 kilometers per hour. Huge sections of the fuselage literally hang over old French houses. After all, they're at least twice as tall as them. And in some places, the distance from the load to the wall is reduced to several centimeters. Here, nothing less than pinpoint precision is required from the heavy-duty truck drivers. A glittering line of trucks driving through narrow French streets. The giant components of the A380 here in Provence have long been an attraction of sorts. Despite the late hour, of course, many local residents come out to see the spectacle. For them, this night convoy is like an Airbus carnival. Always at the same time, somewhere around 2 a.m., the convoy enters the territory of the A380 assembly site near Toulouse. Come dawn, here the main stage of creating this giant aircraft will begin, joining the sections. It's like Toulouse was specially constructed to be the A380 production site. Firstly, it is a very romantic city. It is also called the Pink City because of the peculiar color of the bricks. Secondly, it was here that Antoine de Saint-Exupéry, the famous writer who made millions of people around the world look at the sky differently, was born. Just like our monster, the A380. While the fuselage sections that arrived here at night are being unloaded near the main Airbus assembly hangar, one of the world's largest cargo planes is landing on the tarmac of the local Blagnac airport. It's branded the Beluga, a name it received due to its external resemblance to the enormous deep-sea inhabitant. The powerful transporter has brought the tail of the A380 from Spain for assembly. Most transport aircraft load and unload from the tail, but this plane is unique in every single way. Its nose ramp folds up, and the part of the future monster simply slides out onto a special platform, which slowly and carefully approaches the plane. Only one component of the A380 struggles to fit into the belly of this huge whale, this beluga, the tail. And that's despite the fact that the diameter of the cargo compartment is 7.5 meters and the volume is 1,500 cubic meters. This fish has a large stomach. Usually the most difficult thing is to properly secure the cargo inside the hold. In all honesty, the beluga has a rather exotic aerodynamic shape, and controlling it is no easy feat. And if the balance of the aircraft is suddenly off, it will be almost impossible to land it. A special person is responsible for correct placement of the cargo. Oh, and he flies together with it, evidently to feel a greater responsibility for the work he's done.
We always try to use the aircraft to the utmost of its capabilities. My colleagues and I always calculate what the maximum load might be. It's a fascinating and very challenging job. The cost of a mistake here is our lives and tens of millions of euros. But I am proud to fly on this airplane, of which there are only 6 in the world.
The beluga spends at most an hour in the hangar, unloading, a quick inspection of the aircraft, checking all systems, and its wings up and back. In Spain, the next tail of the next giant aircraft in line is already waiting for its turn. Curiously, the parts of the future aircraft that the beluga brings here to the plant in Toulouse are carefully sheltered and even enclosed in a very thick fabric. The area of this little case here is hundreds of square meters, to protect the elements of the aircraft. There should not be a single scratch on them. Thanks to its impressive size, the beluga can take on board 47 tons of cargo at a time. But because of this, its range of movement is very small. It's more reminiscent of the range of some light aircraft. This giant can fly only 1,700 kilometers. Still, for the distance from France to Spain, that will more than suffice. Now that all the components of the A380 have arrived in one place, all that remains is to assemble them. For the monster plane, Airbus had to build a monster hangar. The weight alone of the metal structures used to build this workshop is 34,000 tons. That's 4 times the weight of the Eiffel Tower. The width of the doors through which the planes roll in and out of the hangar is 90 meters, and there are 8 of those doors. It comes as no surprise that this structure can be seen with the naked eye from space. In total, 3 aircraft are assembled in the assembly shop at the same time. In turn, the 3 main assembly slipways are set up here. When the fuselage parts take their place, the slipway, with a total weight of 1,200 tons, seems to envelop the future monster from all sides. The 3 sections of the giant aircraft's fuselage, plus 2 more wings, are assembled on this slipway like some kind of children's construction set. Added to all that, this monumental work takes only 5 days. Here, by the way, is the place where the 2 parts join. Note that one section slightly falls over the other, so they end up overlapping. Here they are fixed with clamps like this. The sections are drilled and fashioned with rivets like this, and there are 3,000 of them here. So, oddly enough, the place where the 2 parts of the fuselage join is one of the strongest and most durable places on this plane. Still, riveting different sections to each other isn't exactly rocket science. That being said, you do have to tinker with connecting and labeling all the electrical and computer systems. It is this incredibly painstaking and vital job that takes up most of the time.
We have several hundred people working here. With such a workforce, of course, it is very difficult to control everything. Tens of thousands of rivets need to be fitted and thousands of wires soldered. But we've established a setup in which everyone does their own part of the job, and then an inspector comes and checks it all multiple times.
How many times?
How long does a plane spend here?
4, maybe 5 days.
5 days?
Yes, yes.
That's not long. I'd even say it's really fast.
Oh, yeah.
And in these 5 days, you connect all the sections together, install, and even connect all the internal systems, yeah?
Yes, that's right.
Incredible.
This is a very stressful job. The longest we've held a plane here was 7 days. But that only happened once.
One of the trickiest operations is joining the wing consoles to the fuselage. They're moved to the desired position by crane beams, and then precise laser corrections are performed. Around 4,000 high-strength bolts are used to connect one wing to the fuselage. And that being said, fastening the sections is no easier. So that the worker, God forbid, does not mix up and suddenly drills holes in the wrong place, there are these templates here. They're simply applied to a certain part of the fuselage, secured, and then with a special gun like this one here, holes are made through the holes in the template, into which rivets are then inserted. It turns out that there are tens of thousands of rivets in one place, and each one has its own place. What's more, there are also several thousand such templates on the assembly slip, and each one suits only a certain place on the aircraft body. Nowadays, an A380 lands or takes off around the world every 7 minutes. These giants transport more than 1 million people a month. The machine seems to be selling itself. Buyers are lining up and leaving with a smile. But Airbus continues to test and implement more and more new systems on this aircraft. They can only be fully tested in the air, and that's why here at the plant, there's a special plane, a guinea pig aircraft, which tests all new engineering ideas on itself. To be honest, the inside of the test A380 bears little resemblance to a passenger one, but rather a submarine or flight control center. All these complex computer systems monitor 20,000 different parameters every second. Suffice to say, the total length of the cables that connect the servers is 200 kilometers. Now you can imagine what a headache it becomes for on-site engineers when the connection in at least one wire from this bundle here, for example, is torn, and he needs to check every single one to find the fault. When an aircraft needs to simulate a flight with passengers, it's loaded with water tanks weighing a total of several dozen tons. And by the way, these pilots still have parachutes. The crew of a regular passenger plane, contrary to popular belief, of course, does not have them.
This test aircraft is simply vital. It did most of its job, of course, when the A380 was just about to go into production. At that time, everything on it was tested, from avionics to determining noise and cabin temperature. But even today, we don't stand idle. Practically every day, we take to the air to test a new engine or a new system.
The process of testing a new item on this aircraft to serial introduction usually takes years. Aviation is both a cutting-edge and rather conservative industry. The cost of error is too high, so all ideas and materials are checked dozens of times. And this means that on those planes, now being assembled in the Airbus hangars, systems are being installed that were invented and tested several years ago. The final silhouette of our monster has already taken form on the main slipway. Now it is being retrofitted with various units and mechanisms. This device will control the flaps of the A380, raising and lowering them, and with their help, the plane itself either gains altitude or descends. On conventional aircraft, this mechanism is much smaller. However, this is not surprising. The area of the flaps alone is the same as the entire area of a wing on an AN-24. Several teams are working in parallel on the assembly slipway. One is responsible for the tail, the other for the right wing, the third for the left, and so on. It's important that everyone keeps in time with their schedule. After all, just one sluggish group of 4 or 5 people could delay the delivery of the entire liner, and this spells colossal penalties. One of the most critical areas is the installation of the landing gear, which, by the way, contains Russian titanium. This is generally the only element of this huge aircraft where products from our industry are at least somehow used. But to be fair, this can be deemed as a very crucial unit element. It takes on a huge load when landing. And of course, titanium is one of the strongest metals on Earth, the only one capable of handling the task, provided that the wheels don't fail. A set of tires for the A380 consists of 22 huge wheels with a diameter of 1.5 meters each. On top of that, they're so powerful and the pressure inside is so strong that you can't even believe that the sound is rubber, so it completely feels like wood or, I don't know, plastic. And yet the load on these wheels is so great that the footwear for our monster has to be changed periodically. And that means about once a year. The planes that are on the slipways have yet to be painted. After assembly is complete, in this slightly unpresentable form, they fly on their own from France to Germany, where they'll be given the final polish. The only detail that's already shimmering with all the airline colors is the tail. In fact, there's an online camera installed under the ceiling in the assembly shop. The customer of the aircraft can see the feed from it, and from the tail, he can determine which of the 3 aircraft is his and what state of readiness it's in. Generally, the mechanism for selling an aircraft is approximately the same as when selling a car. Next to the main hangar, Airbus built something like a car showroom, or better yet, an air cabin, specifically for potential customers. Here, the buyer can get acquainted with the equipment, make some tuning selections, even order the color of the upholstery. Any whim for your money. Hello?
Good afternoon. Welcome on board the A380.
Please show me what you have here.
Yes.
So if you want to follow me, we'll see some...
Well, do you see how much space there is? I mean, name another plane where you can encounter something like this. It's hard to believe that this is a plane. It feels like the living room of some reception hall. If you look at the cabin, this is the widest cabin in the sky.
The special showroom displays a variety of A380 cabin layouts from economy to business, first, and premium class. Cabins like these are considered the highest of chic. They're called suites here. Essentially, it's a small 5-star hotel room with a bed, an armchair, and of course, a TV and a small table. If you wish, you can even invite someone into such a cabin. It won't be crowded, but that said, you won't achieve complete privacy here, as the side wall of a suite is only 1.8 meters high. According to aviation rules, stewards must see what is happening to a passenger at all times.
So now, as you can see, we're entering the business class cabin, and here we have beautiful armchairs that actually convert into beds.
Everything moves, everything goes lower. I feel like I'm in a spaceship in some kind of sci-fi movie. Yeah. Sweet. There's even a TV. I mean, well, yeah, I'm in the future. It'd be nice to fly in these conditions somewhere from, I don't know, Moscow to Vladivostok. Not like I usually do. Comfort is perhaps the main trump card of the A380 developers. This is where the main emphasis is placed. Airbus is especially proud that this monster has the quietest cabin in the history of world aviation. Standing at the top deck bar and listening to music, it's easy to forget that you're even on an airplane. What's more, in-flight comfort is created not only for the passengers, but also for the crew. Another of the numerous features on the A380 is that it's claimed to actually have the largest and most comfortable crew rest cabin. But it appears to be big only by French standards, as I have to tilt my head a little. Nevertheless, it's got everything you need to relax: a bed, a TV, even a phone. Basically, it's pound for pound a small hotel room. But so that the crew members don't forget that they are still at work, the affectionate French attach the sign "one person only" near each capsule, just in case. In fact, the dimensions of this compartment are standard for any A380. Everything else can be changed. Now, the most popular layout is the passenger compartment divided into 3 different classes. In this case, that means the aircraft has 525 seats. But you can also order a setup where there will be only economy class throughout the plane. Then the number of seats can be increased to 853. However, for some reason, no one has ordered that one yet. Still, the interior and the seat are, as they say, add-ons. The interior of the A380 will again be fitted in Germany, and the plane must fly there itself. To do that, after assembly on the slipway, it will have to pass an extremely tough exam. Once the aircraft is fully assembled, it needs to be fully checked to make sure everything is correct. Interestingly, this process takes the same amount of time as the assembly. It happens in this hangar, plus they also install the engines. As a result, about 3, sometimes 3.5 fully finished aircraft are rolled out from here per month. I mean on average, of course. That means only 35 to 40 monsters are assembled here per year, and the concern's order portfolio includes hundreds of aircraft.
This is where we carry out our testing. Extensive checks are carried out over several weeks to ensure that the electrical and hydraulic systems, as well as moving aerodynamic surfaces, such as rudders and wing mechanization elements, are fully operational.
A thorough and lengthy check is performed on all engine systems. A big plane needs a lot of thrust. And although the A380 can fly confidently even with one failed turbine, it's better not to cause a heart attack. The A380 has 4 hearts, giant engines each packing 70,000 horsepower. And each of them burns hundreds of liters of aviation kerosene in just 1 second. Interestingly, these turbines for the A380 can be made by 2 completely different firms competing with each other. The customer himself chooses which engine he needs, and any of them will fit here like a glove. At the same time, the A380 is the most economical aircraft in its category. It's the only long-haul airliner that consumes less than 3 liters of fuel to transport a passenger 100 kilometers. Compare it with the consumption of your car, and you'll understand that flying works out cheaper. Well, at least when it comes to fuel. After all checks are complete, the aircraft moves out of the workshop and onto the airfield to perform what's known as a pressurized cabin test. It's akin to pressure testing batteries in our homes, which utility workers carry out before the cold season sets in. During this operation, excess pressure is created in the cabin, which significantly exceeds the permissible value for operation, to identify the possible presence of leaks. If everything is fine, pilots are brought on board for the final test. Their task is to make the first test flight. In other words, to get this monster up on its wings. The A380 cockpit is almost the same as any other Airbus aircraft. The company specifically makes them the same so that pilots can more easily transfer their flying knowledge from one type of aircraft to another. But they made an exception for this monster. Overall, the set of instruments is the same, but the displays are almost 1.5 times larger, as a big plane needs big monitors. Romantic French pilots claim the first flight for any A380 is like a first kiss. Unique, each one has their own, and it's always beautiful. After all, only from this moment on can this huge and complex airline be rightfully called an airplane. In the Frankfurt terminal, passengers are still waiting for their invitation to board. The calm, unabashed appearance of the A380 outside still leaves no doubt about its reliability. Meanwhile, inside the monster, tempers are flaring for real. During preparation for takeoff, you can't help but feel that onboard the plane is complete chaos. There's a huge number of people, stewards, technicians, maintenance personnel moving around the plane at great speed and constantly doing something. Laying out pillows, checking food, installing new armrests, headrests, repairing seats. In fact, everyone here has their own job to do, and everything is like a well-oiled machine. It takes only 1 hour to prepare this giant airliner for departure. At the same time, the technicians outside are refilling the aircraft with water and fuel, charting the batteries, checking the landing gear and engines, and conducting an external inspection of the fuselage. While the plane is parked, its engines are switched off, so the air conditioning and heating systems aren't working. And that's why these air ducts here are connected to the plane, and hot air is pumped through them directly into the cabin. This is done so that when people get inside the plane, it will be warm, all for the comfort and convenience of the passengers. After the technicians give the green light, the captain comes aboard. This time, he personally checks all control systems again, verifies the route, and inputs the flight map into the onboard computer.
You know, this is a really good plane, the best I've ever flown in. It intuitively feels the pilot, and should the pilot do something wrong, it will always highlight the issue. On top of that, it obeys a person without question, and the handling is surprisingly easy. Basically, comfort-wise, it's like a Mercedes, while it handles like a Ferrari.
The time has arrived for the passengers on the Frankfurt-Los Angeles flight to begin boarding. Everything is strictly according to schedule. 3 epic paths guide people onto the huge plane in a matter of minutes. Walking along the 2 decks of this giant, they don't know that there are tens of thousands of wires under their feet. Behind the ergonomic upholstery are concealed a multitude of cables and pipes. And when they sit down in an economy class seat, they don't pause to think about the cost of this machine being several hundred million euros. Anyway, all that doesn't matter now. The main thing is that this airliner will lift them into the air in just a few minutes' time. And don't be afraid, this is a good monster.
The offshore oil drilling platform Berkut, located 15 miles from Sakhalin Island on the shelf in the Sea of Okhotsk, is one of the largest in the world. It's a huge 6-story, fully autonomous plant on giant reinforced concrete piles, which not only drills new wells, but also simultaneously extracts several thousand tons of oil from a huge depth every day. It's a real monster with an incredibly complex anatomy. When you approach the platform by air, you realize that it really looks like a bird. Berkut means golden eagle, but the rig looks more like a fat pigeon, which sat down to rest on the surface of the Sea of Okhotsk. But no real birds are to be found here. It's too far from the coast. It takes 40 minutes by helicopter to reach the rig from the nearest town. By sea, 8 hours. Ships typically deliver equipment and provisions to the platform, and personnel for the next shift arrive by air. When the fickle regional weather permits, of course. Well, what can I tell you about Sakhalin? The island sees nice weather, well, not often, but here on the platform it's even more rare. In this kind of fog, for example, a helicopter can't fly. So sometimes the workers are forced to wait for the weather to change for days or even weeks after the end of their shifts.
Ну что тебе сказать про Сахалин? На острове нормальная погода. Прибой мою тельняшку просолил, и я живу у самого восхода.
But how then, here in one of the most inhospitable and inaccessible places on the planet, was it possible to build such a colossal and complex structure weighing more than 200,000 tons? It's very simple. It wasn't built here. The platform was brought here, piece by piece. Berkut is built on a gravity-based structure. That is, unlike floating platforms, it stands firmly on a reinforced concrete foundation which is fixed to the seabed. The base alone weighs 160,000 tons. It was made in Russia, not far from Vladivostok, and towed to this place over 1,200 miles away. Essentially, it resembles an inverted stool. Once the hollow lower part of the base was flooded with water and the platform sat on the seabed, all that remained was to carefully place the upper part of the platform, with all the equipment in the living area, on the legs, sticking out above the surface of the water. By the way, note that on the middle section of the legs of this giant stool, there is a ring of concrete of a slightly different color. This is the so-called ice protection belt. The designers calculated that this section of the supports is approximately where the 6 feet of ice on the surface of the sea would hit. That's why the concrete there is of the highest quality. It's incredibly durable. Previously, on other similar platforms, such belts were made of steel. But it turned out that the ice often tore the metal sheets from the supports during strong winds or storms. Such an incident cannot happen here under any circumstances. The platform is located directly on a tectonic section, and therefore it was designed to withstand even the most intense earthquakes. That's thanks to sliding bearings, like this one here. In essence, they work like our knee joints. Below are ball joints, on top, well, let's call it a patella. In the event of an earthquake, the entire upper part of the platform slides along these supports, thereby dampening vibrations. They say they can withstand up to a magnitude 9 quake, but heaven forbid that ever gets checked. The upper part of the platform was made in South Korea. It took several years to build a 6-story, high-tech, fully autonomous oil refining complex. At the very end, the structure was crowned with a huge oil derrick like a Christmas tree topper. By the way, that was made in Russia, in Kaliningrad. It was delivered to South Korea by sea, then it was carefully installed on the top of the platform with the help of the world's only marine crane with a lifting capacity of 7,000 tons, which had to be rented specifically for the operation. Again, in order to compensate for vibrations during earthquakes, all the pipes and oil wells that go from the upper part of the platform to the lower one have joints here, which are covered with black reinforced rubber cuffs. These couplings allow the pipelines to shift at the connection points relative to their axis and thus provides a guarantee that they won't burst if something happens. However, this is just one of the many ways to protect equipment from unforeseen incidents. The oil platform, like a huge factory, doesn't stop working for even 1 second. It functions day and night because it would take several dozen hours just to start it up again. But you can stop it in an instant with this emergency shutdown button. I was told to not even breathe on it. Later, I wouldn't be able to say it was an accident. That pause would cost the companies several $1 million. When this button is pressed, all the machines stop, all the oil wells are killed, the generators turn off, the circulation of gas and oil stops. In general, the platform completely freezes and goes into damage control mode. This protocol, by the way, is the same for all offshore production platforms, and it was written based on accidents that happened in the past. Right now, there are 237 people on the Berkut platform. In general, this figure fluctuates all the time. Specialists come and go, but there is an ironclad rule. There cannot be more than 240 people. That's because that's the maximum number of places in the lifeboats. There are 4 of them, and it works out to be 60 people per boat. They're a little larger than an ordinary minibus, which means the passengers are packed in here, well, literally like sardines. But during an actual emergency, as they say, there is no room for complaints. Surviving is what counts. Berkut's lifeboats have never been used, and the same goes for the emergency shutdown button in the central control room. It's never been pressed. All the main parameters of the station's operation are constantly flowing into this room. From the dozens of graphs and jumping columns on these monitors, the operator draws a conclusion about the condition of the station, just like a doctor draws a conclusion about the condition of a patient's health by looking at his cardiogram. By the way, since the staff working on the platform is an international one, all announcements are made in English. Only when the operator understands that a native Russian speaker is answering him can he switch to his native language. The diesel engines need checking. If the central control room is the brain of the platform, its heart is, of course, the drilling site. It's located at the very top on the 6th story of the platform. Its lofty position in the structure comes despite the fact that the drill pipes in the drill itself, so to speak, drifters call it the bit, goes over a mile under the platform and, accordingly, deep into the seabed. In general, offshore drilling is one of the most difficult processes on Earth. Honestly, only space flights are more difficult. Here, on an area of several square feet, you might say that you can find all of humankind's achievements in engineering. And if we simplify everything as much as possible, we can say that everything is controlled by this one joystick. It has only 4 options: higher, lower, faster, and slower. Everything is ingeniously simple. Well, this, I repeat, is if we simplify everything as much as possible. But if we go into a little more detail, the joystick controls the manipulator, which in turn pulls out or puts the drilling tool and pipes into the well. They are more or less looking for oil by touch. The Arcutun Dagi Reservoir, on which the Berkut platform is located, is one of the richest in the Far East. Nevertheless, it doesn't represent one huge oil bubble. It's a multitude of large and small cavities filled with hydrocarbons. Dozens of wells diverge from the platform in different directions underground, sometimes going 3 or even 4 miles to one side. Wells, like the mouth of a mosquito, foot by foot, look for oil-filled cavities so that they can then begin to suck it out from them and bring it to the surface. It turns out that under Berkut there's a whole cluster of wells, and every few months another one is added to the list. Anyone who has tried to drill into a concrete wall at home knows that it's best to use drills with serious tips, with special add-ons. Well, here it's about the same. The drill itself is made of high-strength steel, and the cutting elements are made of artificial diamonds. This is almost like a piece of jewelry, although it looks pretty brutal. And in case you were wondering, it costs more than a diamond ring, even though these rocks don't sparkle. This is how more and more sections of long pipe are screwed on top of the chisel, which rotates the steel worm at high speeds. The whole construction bites deeper into the rock, going further and further until the drillers find and form a well. The position of the tool is monitored every second by the drilling foreman from this room. It's called the doghouse by those who work there. Its walls are made of armored, heat-resistant glass and are reinforced with a steel grill on top. Oil or gas can escape from the well under enormous pressure, and these protective layers can save the lives of those who are inside. However, this is already a last line of defense. One level below the drilling site, there is a unit that will not, in principle, allow any such incidents to occur. Generally speaking, there aren't any unimportant machines on the rig, but this one is really one of the most important. It's called the preventer. 2 knives are installed inside, and in the event of an accident, they simply cut off the well along with the pipe, made by the way of high-strength steel, and thereby plug the emergency well. It's never been used throughout Berkut's operation, and hopefully it won't have to be, but it's ready to be employed 24 hours a day. The preventer is only installed on a well that is currently being developed, that is, where the drill is still looking for cavities of oil under the seabed. And the wells that have already been drilled and handed over to operators are considered to be calm and more or less safe. The fact is, the pressure in them is already understood, the density and composition of the hydrocarbons is known, and they usually don't present any surprises. After all that is established, barrel after barrel can be pumped out of here. This room can be seen as the narrow bottleneck of the Berkut Oil Platform, if you like, through which all the oil produced here runs. Each of these thick columns is a well that goes deep under the seabed for up to a few miles. Then they all converge into one large pipe, and through it, the oil is sent off to the mainland. But before that, here at the sampling stands, a little bit of oil is taken from each well. Here it is. The black gold of Arcutun Dagi. It's more brown, really. Sort of reminds you of hot cocoa. Or something. The black rubber skirts you see here on the pipes are, again, the same cuffs that are designed to dampen vibrations in case of possible earthquakes and compensate for any deformation. In total, the platform is designed to accommodate 45 wells. To date, about half that number have been drilled. There is one unique well on Berkut which even differs in color. All the others are labeled in yellow, but this one is orange. It's designated DD1. And its peculiarity is that there's no oil inside. Moreover, the liquid in here doesn't go up at all, but on the contrary, is pumped down from here. This is filled with drilling waste, dirty industrial water. In short, everything that cannot be dumped into the sea is pumped down this well into a cavity from which oil was pumped out of earlier. It's their rather original way of sweeping dirt under the rug, I suppose. This method of disposal, by the way, is considered to be perfectly environmentally friendly. On Berkut in general, they carefully make sure that no oil products get into the sea, judging by the giant colony of crabs which has chosen to hang out on the platform supports, and by the fact that sea lions regularly swim on by. They appear to be successful in that. But back to the spoils. The safety and operation of the wells through which the oil enters the platform is ensured by equalizing the pressure inflicted on it. The thing is, the pressure on the surface is normal, atmospheric, but underground, inside the oil cavities, it's enormous because miles of earth and water rest on it, pressing on the pocket from above with their weight. And so, to keep the oil from gushing from the well in a giant fountain, you just need to apply from the surface the exact same amount of pressure that's felt inside the cavity, that is, equalize it. Special compressors and hydraulic valves are responsible for this. And this is where the hydraulic valves of the wells are controlled. On the outside, it looks like nothing special, just a bunch of valves. Come with me, I'll show you what's inside. Well, do you still think that your bathroom layout at home is a complex one? Speaking of bathrooms and fresh water in general, it's made right here on the platform. Water from the sea is desalinated using this machine. It looks pretty intricate, but in fact, it's just a reverse osmosis filter, the kind that many of us have under our kitchen sinks at home. Salt water from the Sea of Okhotsk is pushed under pressure through a membrane that has many holes in it. But the openings are so small that only water molecules can pass through them. Salt and other impurities are caught on the membrane. All that's left to do is to change the filters on time and to be mindful of water consumption, of course. What is most striking on Berkut is not the abundance of various machines, but how compactly they are all packed in there. The platform only seems huge for a day. Then you come to understand that it's incredibly cramped because here, on an area of just 1.5 soccer fields, they managed to fit a drilling complex, production complex, a full-fledged oil refinery, residential blocks, a helipad, its own power plant, and even a small in-house chemical production facility. This place is called the Chemical Injection Area. It sounds threatening, but it's actually quite simple. Experienced homeowners know that you need to periodically add a special powder to your washing machine so that deposits don't build up in there. Wells are about the same. Chemicals must be added to them which prevent corrosion from occurring, prevent paraffin from sticking to the pipe walls, and so on and so forth. In general, everything is almost like in that old ad. Remember, may the platform serve for a long time. All units are configured to work independently. The need for human intervention has been purposely minimized. In fact, people here, apart from carrying out the hard physical labor on the drilling rig, mainly fulfill a control function. This, of course, creates a deceptive impression that the platform runs all by itself. The only place you're likely to find a crowd on Berkut would be in the holiest of holy areas of the structure, the dining room. Jokes aside, the dining room is one of the most important places on the platform. It works around the clock, and here you can not only eat, but also come at any time, for example, for a cup of coffee. And it also performs one other very important function. It is the main gathering place in the event of any abnormal emergency. Well, and as for the food itself, everything is simple and straightforward. Well, we've got, for example, meatballs, pasta, mashed potatoes. Sure, the Sea of Okhotsk, famous for its seafood delicacies, is only about 100 feet below us right now, but there is no crab, No scallops, no sea urchins, nothing like that on the menu. Everything is filling and safe. At the same time though, it's all very tasty and incredibly high in calories. The portion sizes are huge. During the 6 days that we stayed on the platform, I personally gained 6 pounds. Here, in principle, they approach any production on a grand scale, be it oil production or cooking dinner. And all these processes require a huge amount of energy. I'm not talking about the dining room anymore, of course. Can you imagine how many kilowatts of energy it takes to crank 4 miles of steel pipe underground that has to follow a complex trajectory and twist around like a garden hose? The platform consumes a huge amount of electricity. Where to get it all from? For that, Berkut has its own on-site power plant. It consists of 4 powerful turbines. They run on gas, which is produced here. It's very convenient. You don't have to worry at all about fuel consumption here. Each turbine has a power capacity of 15 megawatts. They generate the amount of electricity that would be needed to power half a city, like Yuzhno-Sakhalinsk. At the same time, the entire energy facility is again managed by only one person, an arrangement almost impossible to imagine on the mainland, but here it's simply the way things work. And although the work at Berkut is incredibly difficult, this is the very case when there are literally no irreplaceable people here. No matter what important position you hold, at the end of your watch, a helicopter will arrive and bring someone who will replace you. Again, only when the capricious Sakhalin weather permits it. There's almost no wind blowing here now, but sometimes it gusts so hard that this net has to be kept on the helipad. It's called an anti-slip net, and it's necessary to keep multi-ton helicopters from simply being blown off of here into the ocean. So despite the fact that people here live, well, as in that very song, near where the sun rises, the place is actually quite far from being a romantic one. However, many of those who work on Berkut disagree with me. It is incredibly difficult, dangerous, and critical work, but at the same time, incredibly interesting work. And even our film crew, who due to bad weather got stuck on the Berkut platform for almost a week instead of the 3 days we planned on, was reluctant to fly away. And who knows, perhaps we'll come back. The life cycle of this monster is calculated to go until 2050.